Ah, it works. Mostly. Oh, what is going on here? My God, this. Oh, my light's not even on. It's been a long week. It's been a very long week. But let's do that again. Let's actually let's enjoy the show while we can. Now, there's a lot of dodgy stuff going on here. This is not doing exactly what I was wanting it to do, but it does mostly do what I wanted to do. So I can move over, throw, get it in the cone. How good is that? My God, this is a lot of work to get to this point. Let me reset things, and I'm going to turn the power off because that fan is loud. Wow, I'm very relieved that that worked. I gave that probably last night when I was finishing this up. I gave this like a 30% odds of working during the stream, but I figured some stuff out this morning, and yes, it's very good now. It's, yeah. I want to preface as well this stream that I did not get very much sleep last night. I've been very sleep deprived this whole week. It was a lot more work than I was expecting it to be to get to this point, both in the hardware side, like taking the old hardware from the old Ball Butler and then putting it into the new Ball Butler, as well as the software side. I knew that the software side was going to be a bit of a pain, but it actually, all things considered, actually went pretty smoothly. ChatGPT is fucking amazing. It is so good. But yes, so I went to sleep at like 3 a.m. last night, so I'm a little bit tired, and yeah, so please excuse any weirdness. All right. Hello, Lolis. Good to see you. So yes, it works. Ball Butler can throw into a spot. However, it's not doing quite what I wanted it to do. So my goal for what I mentioned last week is that my goal was that I could get the basically have the whole system working very, very similarly to what it would be in like actual situations. So that the Ball Butler would be tracked by the motion capture cameras around the room, and also being tracked would be this catching cone using these markers, and then we can like dynamically position. My hope was that I could just like hold the catching cone kind of arbitrarily, and then Ball Butler will be able to throw into the cone. It was about 2 a.m. last night when I first was able to get messages being sent between the Jugglebot computer, the Jetson, and Ball Butler, and that was without any motion capture stuff being integrated at all. I did boot up the cameras and I started going down this rabbit hole, but then I realized that the tracking on my desk, like where Ball Butler is sitting right now, the cameras can't really see that spot. So it's really not a very good spot to be like prototyping and testing out my motion capture system, especially at 2 a.m. when I don't really want to be like thudding balls on the ground because other people sleep in this house. So I realized that it might be worth lowering my my expectations a bit, and just instead, I'm sending now just a target position. So I tell Ball Butler, I want you to throw so that the ball ends up at this XYZ position. I'm not doing anything too fancy with the timing right now because it's just trying to throw into the cone, so it doesn't really matter what time it arrives. And then I basically just like fine-tuned the XYZ position, leaving the catching cone exactly where it was in the tripod until eventually it was getting in consistently. Prop Guru, or is rocking the robe. Nice. Yeah, well, I was going to say that you might not be seeing too much more of it because it's becoming summer now in Australia, but given that I'm not going to have another, I probably won't have another stream this year. You might see me next time in the robe again, in winter next year. Hopefully I'll be back before then, but yeah. And it's good to see you as well. Nice. Usually working. Well, I'm glad you got the day off. Hope you're enjoying it. Oh, yeah, it's public holiday today, isn't it? Yeah. Yeah, all right. Where do we begin? So much stuff. Yes, so Ball Butler works mostly. And by this mostly, I mean mostly the motion capture stuff is not working. So, and that's purely just because I haven't actually integrated that functionality yet. Everything else, mostly, is working. So we've got, just as like a broad overview, yeah, I've got the inverse kinematics are being handled on the Jetson. So when I command a target XYZ position, the Jetson will go through and figure out, okay, what angle do we need to rotate at? What pitch do we need to rotate at? Which I'll talk about more in a sec. And what throw speed do we need? And then once it figures out what those parameters are, the Jetson then sends Ball Butler this can frame, which is very, very similar to what I showed last week, except that the only difference that I've made is that I've made the pitch axis angle is now 2 bytes instead of 1 byte, which just gives us an insane precision. Because why not? If I'm going to have there's no point in having an empty byte, or an empty byte if I can just use it to get more precision on my data. So that's always good. And then so then on Ball Butler Teensy, it's doing everything else. So it's taking in these parameters, and then I might actually just show you, just quickly. I also have uploaded all this to GitHub as well, and there's a link in the description if you want to check it out in more detail. But yeah, this is a pretty mega script that I've got. I've definitely never dealt with Arduino code that is this complicated, and I am extremely relieved that ChatGPT has gotten better at the rate that it has, because this would not have been possible for me to do 6 months ago or a year ago. Yeah. So yeah, we've got a main script that basically just handles all of the high level stuff, and then I've got everything else split off into its own little functions. So we've got a script and a header file for the yaw axis. So this will allow me to set, I might show you dynamically. Yeah, this will be cool. All right, so let me go to here and then do this, and then give me 1 second. I've got to add another camera. Why are you working, Prop Guru? It's a public holiday. Not supposed to be working. Where is it? Oh, there it is. Whatever. All right, no, I'm not going to do that. Okay, yeah, I'll just go through describing it. So let me turn this back off. All right, yeah. So I've got to cut a long story short, essentially, there are all separate little scripts, and they all handle a little part of the puzzle. And then in the big script, we just combine them all together and then send off the information where it needs to go. So when Ball Butler takes in this information, it sends off the desired yaw angle to the yaw controller, which was actually surprisingly not too bad to set up. So I actually do want to show you this, but it might work if I do it this way. And now I can add this and this and this. All right. I know I should have gotten this set up before, but I didn't, so here we are. All right, there we go. All right, so let me turn this back on. And I'm pretty happy with this. Some things don't work every single time. I refuse to believe that computers are deterministic. People say computers are deterministic, but you use a computer and then you realize that it's not. Literally just then, I did the exact same thing twice and had different results. One time it homed the hand, the other time it didn't. What's going on there? All right, so I/ChatGPT have made this script that allows me to control. So in the Arduino code, so I'm currently plugged in over USB to the Teensy, which obviously won't do in normal operation, but this is just for debugging purposes. I can control the different axes separately if I want to. So I can go yaw. Let's say we want to move, and let's say we want to move by 50 degrees. Now the yaw axis will turn around, but how do we know whether we've actually made it to the right spot? Well, we can add let me do health because I can't remember what it was, YT. We now have telemetry. So we can see that, hopefully that's big enough for you to see. We have a measured position of 50.1 or 2 degrees and a commanded position of 50 degrees. Pretty damn close. But let's say, what if we want to try, we can move by a relative amount, or we can move to an absolute amount. So M is relative, I don't know why it's M. But yeah, so we can go 30 degrees back in the other direction. So we should be now at 20. And we can see as soon as we get to 20, we stop, and it actually cuts the power to the, like it. So this was actually, I was expecting this to be a bit more difficult than it was, because in this axis, you may remember that the yaw motor, like the brushed motor that's driving this axis, it can't operate at a low speed. If I try to run it at a very low speed, it just doesn't have enough torque to get anything moving, and it makes this like really gross grinding sound. Not very nice. Which I was expecting to be a little bit tricky in terms of positioning it, because if I was like telling it to go at like minimum speed and then stop it at like as fast as I can, I could get it to like tick over a little bit, but it didn't feel very precise. Turns out this is actually not that tricky to solve if you have a computer controlling the motor, because what it can do is it can do that pulse of like minimum speed very, very, very quickly. So it basically just does, like, I can control like 1 degree increments. So if we want to move by 1 degree, let me go back to camera. Like, you might not even be able to see it moving, but it's moving 1 degree at a time. And of course, like, it's not getting exactly spot on. I do have a tolerance set here for, as long as it's within half a degree of where it's supposed to be, then we just call it there. And I could, and I will, well, I intend to play around with changing that tolerance a bit to see if we can hone in even more precisely. But this will be a recurring theme during the stream, is that I was getting things to the point where they worked and then moving on. And yes, that has definitely, that's not a sustainable way to work on a project like this. It definitely will require me to go back and redo things a bit more properly. But for the purposes of getting stuff to work at a particular deadline, you can't really do it many other ways, I think. James says it's cosmic rays flipping bits. I mean, it could be. It could be. Yeah, so, and one other interesting thing that I experienced when going through, like, setting up the yaw axis so that it could, like, hone in properly. And also, as well, we can do, like, big commands. So if we want to move by, like, I'm wary of the cable that's connected in there now. But if we want to move by, like, 200 degrees, that's getting kind of close. Let's go back. Another 200 the other way. It speeds up at the start while we've got like a long distance to go, and then it gradually slows down until we get there. And yeah, one thing that I found was quite interesting with this is that at the beginning, ChatGPT was suggesting we should have a 1 kilohertz, whatever it's called, like the rate at which we are sampling, like the rate at which we're looking at, okay, we are here, we want to go here, so we need to power by this much. And it would do that 1,000 times a second. It would update 1,000 times a second saying, we're here, we want to be here, this is how much power we need. And so, of course, the power level was presumably, especially because there's a little bit of noise, it seems, like the fact that this measured position is varying by so much, I'm kind of surprised by, and I wouldn't have thought it should be that much noise. Who knows? But because there is that noise, if we're processing this at 1,000 frames per second, that power out is going to fluctuate a lot. And something that was quite interesting is that when, I don't know exactly why this was happening, but when the yaw axis was getting close to its target, like within a couple degrees, it would just stop and then make this really gross grinding sound, similar to the other one that I was describing. And it just was terrible. And I was like, oh, this is kind of weird. Like, what should I do about this? I asked ChatGPT, and ChatGPT goes, your problem is that your loop is not fast enough. Let's go to 4 kilohertz and try again. And I read that and I'm like, no. 1 kilohertz, like we're doing the hand, which is throwing, like very precisely moving that axis in order to throw the hand. That is 500 hertz. There is zero chance that we need a faster refresh rate, or like, what's the word? I can't remember the word off the top of my head for that. The faster like sampling rate. There's no way we need a faster rate for the yaw axis. So I thought, I'm going to go in the opposite direction. I'm going to try slowing this down. And I went to 100 hertz and it just worked straight away. There are, like, this is like a PID controller, ultimately, that is setting how intensely we need to spin. And I had tuned that stuff a little bit, but it just, like, kind of worked with the first values that ChatGPT suggested, except for that command rate. And everything else just works. I'm like, all right, cool, done. Put that aside. That stuff works. So now we can turn off our yaw telemetry. So now let's have a look at the next axis, the pitch. And I need some help because I can't remember the commands. So for this one, we don't have a rolling telemetry. Unfortunately, that has not been implemented, but we can see like a one-off status, so we can see that right now we're at 90 degrees, and this does update. Like if I manually move it around, it will update accordingly. But then we can also just set a value. So we can say anything between 12 and 90 degrees, this is measured from the horizontal, we can send it to. So we can go to like 50 degrees and it will tip down. Now this does need a bit of tuning. I need to spend a bit more time getting this working nicely, because you can see that it tends to overshoot a bit. And actually this might be, well, this will be easy to see if we change this. And then we can see the GUI. So let me turn... why do I not have the right things? Alright, no, you can just look at it. Getting the camera views is so frustrating. Alright, yeah, you can just see it. So, yeah, we can go all the way down. Let's go down to like 30. And you can see it overshoots a bit before it comes back, before it settles in. And there are some instances, like right now, it spends a bit of time kind of settling in. I need to tune the controller a little bit better, because this is actually causing some problems. Like when I am commanding a full throw, like if I chuck the ball back in and we do a throw, let me put the cone back. So if we do this big throw, or like a proper throw, then sometimes the pitch axis, I've had to manually set that delay between... Oh, he didn't see it. It did go in. You gotta believe me. It's there. I've had to manually set that delay as 3 seconds, because if I try to throw any sooner, or if Ball Butler tries to throw any sooner, then the pitch axis is like halfway between settling into its correct position, and it tends to vary by quite a lot. Like you can see as that moves around, it really spends a couple seconds honing in. So yeah, I definitely need to work on that tuning a little bit. But, you know, it works, mostly. Definitely the theme of the day. It works mostly. Alright, so then the last axis is the throw axis. So we can do some smooth moves, and we can go to like a certain position. And let me actually... You can't see this very well, so I'm gonna spin the yaw axis around. Let's go by like -100 maybe. There you go. How good's that? And let's just zoom in a bit as well, because we don't need the camera to be so far out. Nebby says, been a while since I've been able to watch. Great to see it's accurate with the throw. That's awesome. Yeah, it is. It's very repeatable, except for the pitch axis taking its time to zero in. It seems to be very repeatable. Yeah, I've got a lot of stuff to say about that. But yeah, so we can smooth move, and we can go between like the... Why did that not move? Rejected. Oh, because our limit, it's too big. It's going up to 8. And something that I quite like about this, I don't know exactly why this is the case, but you may recall that sometime previously, earlier, I was mentioning that I'm trying to get the hand system to be smooth enough that I can just like tap the ball and it will glide down to the bottom. I don't know if it's because we have an extra pulley in here compared to the Jugglebot system, and I'll show you the CAD in a bit. I don't know if it's because of that extra pulley or what, but there is a bit more friction in here, and that kind of works in our favor though, because what this means is that I can command the hand to move, and then as soon as it's done moving, it turns itself off. So it's just sitting there idly and not drawing any power, not heating up, not doing anything like that. It's just turned off, and it will just hold its position until another command comes in. So we can do the smooth moves, and then we can also do throwing. And I haven't pushed this too far, and I don't really want to... We'll see how we go. But I can send a throw. So when I'm sending throw, I say throw the speed that I want to throw at. And I don't know how how like accurate this is to reality. If when I command 1 meter per second, if it's actually throwing at 1 meter per second, I don't think it is. But then the throw, like, yeah. I need to do some more calibration on this as well. So I do the speed, and then I do the time away from right now when we want that throw to happen. So it goes down, 1 meter per second throw, not very interesting. Theodore says, is the encoder output of the pitch axis also noisy? No, it's not. No. So that output, we have yeah, no, short story. From what I can tell, it's not. To like 2 or 3 decimal places, it's not. It's like actually quite clean. So let's go up. Let's go to 2 meters per second. What? Ah, okay, 1 second is too soon. We need at least 1.245 seconds. Because I have this right now, I have it set up so that when it goes down, it calculates how much time it will take in order to move down to the very bottom in a slow manner. And then it will pause at the bottom for some amount of time, and then it will make the throw. And if there's not enough time, if I have commanded a throw to happen in like 1 second, as I just did, but it's going to take 1.2 seconds to be fully ready for the throw by going down and waiting, then it says, no, I can't do it. You need to give me more time. So let's give it a bit more time. Now it goes down. And now, of course, Ball Butler is not designed to catch, so this makes this testing a little bit annoying because I have to just manually catch the ball every time. Let's go a bit faster. Let's go to 3, and let's maybe zoom out a bit. Yes, James, that's a very good way to say it. It's neutrally buoyant on the linear bearing. Absolutely, yeah. It just like it's very easy to move around. Like you can see, it doesn't take much force, but then when you stop moving it, it just sits there. Which is kind of nice, but it also means that the motor's working harder than I maybe want it to. But also, it can do big throws. So it's 3. It's like, yeah, that's all right. We're getting there. I don't think I've tried 4 before. So let's. That's pretty good. I think that might have been out of frame. And of course, this is the same everything pretty much that Ball Butler is using. So it's very, very capable. Let's try 5, and then I'm not going to push it past that because I've definitely never gone this far before. That hit the roof, and we got an error. What was our error? This is good science, because I haven't done this before. Alright. Okay, this... I was going to talk about this a bit later, but maybe now is a good time. Oh, actually, just keep this in mind. The ODrive S1, you can't actually see that. Let me spin it around so you can get a better look. What do we want? We want we want to move... We want to untwist the cable, so we probably want to go like... I don't know, 270 degrees from here. Oh, that was pretty spot on. Oh, we're connected now. Okay, we got to spin out. That's strange. Alright, I've got to look into that a bit more. But yeah, so we got an error on the hand, but that's fine. That throw hit the roof. Ball Butler's never going to need to throw that high. I'm not worried about it. Let's turn that fan off. How is the repeatability of throwing in an arc? I haven't tested it too thoroughly. I've probably only made a total of like less than 30 throws all up on Ball Butler. Like this, less than 24 hours ago, I could just control the yaw axis, and that was it. And I had a bit of a marathon sprint from like probably like 6 p.m. last night. I had a bit of a break for dinner, and then until 3 a.m. it was just like, all right, yaw axis is good, pitch axis is good, throw axis. Yeah, it's been a long process, but yeah, I would say because I've only done it like less than 30 times, I can't say for sure, but I can say that I think it's pretty close to being repeated, like very repeatable. Because like I calibrated this, like the throw into the catching cone. Like maybe we'll turn it all back on. And that shouldn't do that. That shouldn't, it homes, the yaw axis spins to 0 when it boots up, but it's not supposed to do that. It's supposed to stay where it is. And then, the hand didn't home, but it should have homed. Let's just turn it back on, and I bet now we'll home. There you go, now it's homing. What's going on? Yeah, so if I'm sending like this command to throw into the catching cone, and this is coming from the Jetson, then this, from what I can tell, is pretty repeatable. Like if I'll just run the exact same command again. Like it is, the catching cone itself is moving a little bit every time the ball hits, but... See, then it missed, yeah. It's pretty close. I think it's, for the stage that it is at, I think it is repeatable enough that I am happy with it. Yeah. I'm definitely expecting more tuning to go a long way to getting this to be more precise. Yeah. That is amazing. Thank you, James. I was in a code hole. Yes, I was deep in the code hole. Yeah, this Arduino code is a total of 2,700 lines. Wild. And ChatGPT can handle most of it at the same time. It's pretty damn good. All right. Let's continue with the slides. Yeah, so all right, I've got a collection of photos here now that I just I wanted to show at some point. I want to show at some point, and I didn't really have a good spot to do it, so I figured I'll just do them all at once. So this is the inside of Butler, and I might show a bit later. Once I know that I'm done with all the demos, I can like take it out and show you if we want to. But yeah, it was actually, I don't know, it was an interesting experience getting these cables around the back here. So if you don't remember this, I'll show you on the CAD. This base, I've designed it so that it can open up so that I can get access to all of these electronics fairly easily. All that I need to do is unscrew a single screw in here, and then once that screw's done, I can flip this down. Of course, these connectors do come with the lid here, but just because of the way that I've modeled this in Onshape, it's kind of hard for me to make them move and not break other things, so they stay there in the CAD. And then yeah, so there are cables that need to run from this blue guy in here. You can see that little thing here. These are some cables. They need to run out from there and then go down into the teensy board over here. And yeah, getting those to be the right length so that they didn't like pinch or get pulled too tight when it's fully open was a little bit tricky, but honestly, like a lot of the lengths were exact. Like these are the same cables that I used before. Like this white one is the exact same cable that I used in the exact same spot before, and it just happened to be the perfect length. So that was very nice. Very happy with that. This, yeah, I don't really have too much else to say about this. Yeah, it worked just as well as I hoped it would have. I really love this. I strongly recommend, if you are doing anything like this where you need to have electronics in a box and you don't know exactly where they're going to be placed and you want to have a bit of freedom with where to put things, this like multi-board layout that I've done here, and you can see it a bit better in the CAD, like these little tiles in here were amazing. It just makes it so easy to snap down little holding things wherever you want. Like because I had the cables a certain lengths, I had to actually move where my bus bar multi-board things are, and that was just trivially easy because it's all multi-board. I can just put them wherever I want. Very, very, very good. Definitely recommend. Yeah, I don't know what's causing this. So we have let's not stage. Also, Logitech is giving me the shit. Yeah, there's a link in the description for this CAD if you want to check it out as well. As always. Yeah, so this big red, it's red in the CAD, it's blue in real life because I didn't have enough red filament. Story of my life. That is attached with 4 screws. These 4 screws around here, they go through the lid and into the ring, into the big gear. All 4 of them go in by the same amount, which is, I think it was like 7 or 8 mil, something like that, into there. Actually, we can just measure it. Let's not be lazy. Oh, no, it's not. 4.5 mil. Maybe this is the problem, that it's not biting in enough. Because in some spots, it's really hard to capture this on camera, but this little gap here is not there the whole way around. So I don't know. I suspect what's happened here is that the print has warped ever so slightly. This is PLA, so it's not usually prone to warping, but maybe it did. Or it shrunk a little bit. And because the bearing that I have screwed this into is like, that's not going to flex at all because it's made of metal, I think that there might be some weird internal forces in the ring. And I wonder if it might be better to like print the ring off in multiple pieces, and then that way like the collective shrinkage will be a bit less, or I'm not really sure. But I have noticed actually that the amount of backlash that is present in the, like if I manually move or try to move the yaw axis, in some positions I can get like a little bit of wiggle out of it, but in some positions I can't move it at all. So I think there's definitely something weird going on there, but it still works. So we move on. Yes, I have also added a thermistor into the hand motor because I don't really want to continue burning my hand motors. They are very annoying to re-string into that position. And yeah, so I've added a thermistor in here. I am aware that because I am pumping in a lot of current into the hand motor, it will be just a matter of seconds before the hand motor overheats in some situations. And I think that this thermistor will be a little bit too slow to respond if something goes wrong and the hand is just like driven into the top and it just keeps trying to drive into the top, which is the sort of situation that has led to it being burnt out in the past. I think if that happens, I don't know if the thermistor will actually be able to do very much to help with that because it's going to take so long to catch up to be like, oh yeah, we're actually super hot right now. But it might help. It might do something. And at a minimum, if once this system gets working, it's possible that we could have it. I know I've said in the past that I'm not planning on doing this, but it's possible that we could have it churn through balls pretty quickly. So we can just like collect, prepare, throw, collect, prepare, throw. And then maybe that gradual, I don't know, it'll be good to at least be able to monitor how that gradual temperature is rising up. And yeah, so that's just like shoved into like the back of the motor. I have added thermal paste as well between the thermistor and the motor coils. So hopefully that should be a fairly accurate representation of the motor temperature once it catches up. Yes. Okay, so the biggest thing on the Teensy board that I've had to change is I had to change the buck converter because now we are running everything off of 24 volts instead of 12 volts. The old converter that I had only goes up to 15 volts, so I had to swap to this one, which goes up to 30 something, I think. But it's basically doing the same job. So this is, you can see there's a little dab of solder on the little 5 volt terminal there. So that's taking 24 volts, spitting out 5 volts. And I did also have to change two things. One, I'm going to return to this image in a sec. But one of the things that I had to do was to merge the two CAN buses. So originally I was planning on having CAN coming in from Jugglebot over here. So this would be like CAN, like Jugglebot CAN. And then we would have CAN coming out over here, internal into Ball Butler. But over the last couple of weeks, we realized that for now at least, it's a bit more clean. It's a bit easier to just have these two CAN buses be merged so that the Jugglebot CAN bus is the exact same as the Ball Butler CAN bus. And to get that to work in the easiest way possible, I just bridged the CAN high, CAN low. So like this is like over here. So these two CAN high, CAN low, these guys are now just bridged between the two transceivers. And that's all I had to do pretty much. And that works. And yes, some Dodgies. There are very many Dodgies in this in this setup right now. The first, this is in no particular order as well. This is just the order that I happen to remember things in. The slots in the hand spool end mount, I had to change them because this is, I'll show you in the CAD. This is fucking Logitech is really shitting me. I'll probably have a rant about that a bit later. So over here, we have the hand motor. This is being supported on the back. We've got some screws holding it in on the back here. You can see where those 4 holes are. But then, so that it doesn't like cantilever down, we want it to be supported on this other end as well. And in the past, when I've done this, I've just had single hole, like the CAD has just been right, is essentially the TLDR. The CAD is correct, and we don't need to do anything else. So I just make straight up just normal holes, and then everything aligns perfectly, and it's all nicely, like everyone's happy. The motor doesn't have like extra drag. But for some reason, I need to get a good video of this, and I meant to before the stream, but it is what it is. For some reason, the hand motor spool is not perfectly like true. Like, yeah, basically as the hand motor spins, you can see there's like a little bit of wobble in the spool for the hand motor. And I'm a little bit surprised by this because the motor is like obviously quite true, otherwise it wouldn't really work. And the spool this is one of the ones that I had made from JLC PCB, one of the aluminium ones, which I actually have one more over here. One of these guys. And like this is made of aluminium. I would expect that they would just like do this on a lathe, trim it down, and it would be like perfectly concentric. But maybe not. So I don't really know what's going on there, but for whatever reason, when I just had the straight up holes, it was not lining up properly, and so I had to change these over to slots to get everything to be positioned correct, which I guess isn't like too dodgy in and of itself, but I don't love that I had to do that. Like anytime the CAD is different to real life, it really makes me kind of a bit nervous because I'm like, what else am I not seeing that is not correct as well? Like I just happen to see that this one doesn't match, but what else doesn't match? You know, like it's happy days when everything is in agreement. I also realized over the last couple of days that I actually don't have a fan inside Ball Butler. So this nice big like plastic box that I've got in here, it's possible maybe once the yaw motor gets cooking, like gets going really fast, that might be putting out a bit of heat, and that heat doesn't really have anywhere to go. And I also don't have any temperature sensing elements inside there. So I don't really know if I should be concerned about that or not, but it's a thing that exists. So, yep. I'm just kind of maybe foreshadowing for in the future if something goes wrong. Theodore says, about the yaw ring gear, bolts are not the best locating features. Even more so if it needs to form its own threads. Yes, which it does. The warp could be from the bolts not allowing the plastic to sit where it wants to. Yeah, it's tricky though, because I don't know what other features I can use to align them, because in the bearing I only have 4 holes. That's it. There's just 4 holes going straight through, and those are the only things that I've got. And I need the ring to be beneath the bearing. I could have probably, like if I made the ring, I actually saw just recently someone made like a table, like a rotating tabletop thing to take photos of stuff. And I realized, I saw what they did was to like basically make the ring part of the lid. So like when I print the lid off, instead of this like lip edge that I've got in here, that would be the teeth for the gear. And that sort of thing would work. That would be like this, the lid and the ring would just be like the gear would just be one solid piece, which maybe would make the warping worse, but maybe not. It would definitely make the whole thing connected exactly how I want it to be if I can have no warp. But I don't love that gets rid of my gear reduction a little bit, and I've already done it this way. So it's not super easy to change that. Yeah, that would definitely require a lot of other things to change. But yeah, without doing that, with keeping the gear in the position that it's in right now, I really don't know how else to locate it. And it's a bit tricky. Maybe I could make it a bit deeper and have the bolt like bite into it a little bit more, but that would require moving the motor down a little bit, which I think would be fine. I mean, it's pretty close to the bottom there, but we can like trim out a little pocket for it. Yeah, there's some options. And actually, this reminds me, one thing that I realized when I first actually had this in my hands and I was like playing around with this hinge, which worked perfectly, by the way. I meant to check last week's stream to see what I actually showed you in last week's stream, because I've done a lot of hours of Ball Butler work over the last week, and I can't exactly remember what I had done last week. So forgive me if I'm repeating stuff. But when I had this printed off, I realized that these tolerances in here are way bigger than they need to be. Like on the actual thing, these are like full-on gaps, like big gaps. And if this was to the point where if this was on the top of Ball Butler for whatever reason, if that same situation was like up, I would probably be a little bit concerned about dust getting in there. Thankfully, this is on the bottom, so it doesn't matter at all that those gaps are quite big. But yeah, definitely if I was to do this again, I would make those tolerances a bit less. And of course, the reason I had the tolerances so big in the first place, like there's a 1mm gap the whole way around. The only reason why I made that so big in the first place is because I really did not want to have to print this off again. Because this whole thing, this guy and this guy are all one piece. So that was a big print. And yeah, I don't love the idea of wasting filament. But one thing that I did that was kind of stupid to do was to do with the support for the yaw motor over here. So I knew that I wanted to have a bearing supporting this ring, because as we figured out probably like 6 weeks ago now, whenever you have this kind of like swept gear where the profile is curving, whichever direction, when you drive that, the gear is going to want to move along the motor shaft. It's going to either want to move away or towards the motor shaft, depending on which way you're spinning. And I believe. And so to stop that movement from happening, I do also have now, this is being held in by a grub screw. So I've got a T-nut sits in this like square hole in here. And let's go on a view like this. So a T-nut sits in here, and then a grub screw comes in, and that much more securely locks the gear onto the motor shaft. However, it's possible that it'll still want to move along the motor shaft, and so to stop that from happening, we have this bearing in here. And yeah, I knew that I wanted that to be supported, so I made this little supporting thing. But for some reason, I wanted that to be tucked away nicely inside the external box when it's closed up, so that it looks like this. But that's stupid, because that means two things happen. One is that this support is now thinner than it otherwise could be. Like if I extended this support all the way out to this edge, we would have an extra, 3 mil of thickness on it. That's pretty significant. That will make that a lot thicker. As it is right now, that can definitely wobble back and forth a little bit. And the second thing is that I've had to like cut out a little cavity in here to fit this feature. And what this means in practice is, because I have so much tolerance in like all of this stuff, like even in the hinges, well, especially in the hinge, I've added quite a bit of gap just to make sure that it printed perfectly fine and I didn't get stuck. So because there's so much tolerance everywhere, this whole thing can kind of like shift around a little bit. And when I close the lid now, what often happens is that this edge will catch on this edge in here. And I have to like manually push the whole thing over to the side a little bit to get it to close. That was stupid. I should have just made this continue the whole way out to the edge and then have the cutout in the main box part be the same as what we have here, where there's like a full-on cutout and it just like slots in. It is a little bit different to this one over here, because this one is at the like opposite the side of the hinge, so it doesn't have any risk of like hitting like when it's on like a diagonal like this. But I should have done more or less the same thing. This was a silly choice. But it works, so. All right, another dodgy. Now that I think about it, maybe this has something to do with why we are getting noise on the yaw encoder, maybe. But I don't know. So you may recall, I was going through my my schematic, which I can show you here. Again, there's a link in the description for, if you go to the GitHub repo, you can find this schematic. I was having a look through my my schematic a couple weeks ago and like looking at pictures that I had taken of all of the electronics, and I realized that according to my photos that I had, the yaw encoder was being powered by 5 volts. And this is bad, this is not good, because this yaw encoder is being fed straight into the teensy. So these outputs, yaw CSN, let me go on the highlighty one. Yaw CSN goes to the teensy. Yaw clock goes to the teensy. Yaw miso goes to the teensy. Teensies are not capable of, they do not support a 5 volt signal on any of their pins. So if, my understanding is that if you put 5 volts on any of the teensy pins, that pin will break and it will just not be functional anymore. And like at minimum, maybe other things will break as well. Yeah, so I was like, what the heck is going on here? Like, according to my photos, this encoder is being powered by 5 volts, which I would expect would mean that it would be sending out 5 volts. But somehow it worked. So I just assumed that maybe my photo was not up to date and I had actually just wired it to 3.3 volts. But it turns out it actually was powered by 5 volts. Once I took apart the old ball baler and I had a close look at things, I realized it actually was. Even though the encoder itself was configured for 3.3. So what this looked like is like this. So this is from the data sheet. And it's telling us if we just want to be able to read data off of this device, and if we're powering it from 3.3 volts, what we need to do is connect to these 2 pins and also MOSI. And you can see that's what I've got here, this little solder joint and this white cable. They are like the power line. And then we have SS, SUK, and MISO are going off to the microcontroller. But I had this like this, but going back to this other photo that I was going to show before, but what I've got is the line that is powering this. Like if I show you the schematic, this power line, what is labeled in my schematic as 3.3 volts, was actually along here. And prior to me drilling this little hole in here, which separates those 2 channels, this whole line was 5 volts. We were getting the 5 volts straight out from the buck converter, sending it off to the encoder, and then telling the coder, hey, I'm setting you up for 3.3 volts, but I'm actually just going to give you 5 volts. And I have no idea how this did not break. I legitimately do not understand how this didn't work. The only explanation that I can think of is that whoever designed this this like breakout board, this like prototype board for this encoder, they must have just figured, you know what, someone is gonna mess up and power this by the wrong voltage, so let's just make it compatible. Let's make it so that it's safe at being powered by 5 volts, even if you set it to 3. Even though this diagram says you can only go up to 3.6, I guess 5 is fine. I don't really know. Definitely not advisable, but it also didn't break, so that's good. Yes. Now we're getting into frustrating land. So the ODrive S1 only initializes when it's being plugged in over USB. So I want to show you what this looks like. So if I have this unplugged, and you saw, so the way that this is supposed to work is that when the TNC receives power, it will home the hand and it basically homes the hand and then gets everything ready. So like the pitch axis turns on and it's just like sitting there, like holding its position, and then everything's ready to like receive commands. But I've noticed that if the ODrive S1, which is powering the hand, if that is not connected over USB, then it does not initialize. So if I turn the power on right now, are you kidding me? That is literally the only time it's ever done that. That is such a funny example of like things not going right in real time, because it kind of is going right. Okay, here we go. Now we've got the red thing. All right, so we've got an error here, and hopefully you can see that red light coming off of there. And where this gets really frustrating is that it's like, okay, cool. This has got a red light. It's got an error. I can just plug it in, and then I can see what the error is. Because if I know what the error is, then I can handle the error. But, oh my god. Maybe I just needed to refresh my computer or something. Last night, every single time this happened, like let me turn the fan off. This is so funny. If I didn't have the ODrive S1 plugged in over USB and I powered the system on, I would get this red light. But then if I tried to plug in the USB while the red light was going, it wouldn't connect to my computer. It would say like there's some like transfer error, and it wasn't able to like connect to my computer. So, but then if I turned all the power off, kept the USB, like plugged the USB back in, turned everything back on, it would work. So it's like this kind of like phantom error where like every time it was there, I couldn't see what it was, but every time I could see what it was, it didn't appear. And this was just driving me mad. But I guess it's not a problem anymore. Maybe, I mean, the error is still occurring, but at least now I can see what it was. It was saying initializing and disarmed for some reason, but yep. At least now I can make progress on that. That was driving me mad, and I had no way to move forward on that, so I just kind of ignored it. And that's why I have always just been leaving that plugged in. Now, one thing that I am kind of a little bit, not worried, but like unsure about, is that on the ODrive S1, if I have it, like when I have the system powered off, the ODrive S1 obviously says, hey, I don't have enough power, I can't turn on. And then when I do turn it on, there's this weird like brake resistor control, like error checking thing that the ODrive people have set up, where if there's one of like a specific set of errors that are present, then the brake resistor will disarm and it will not allow the axis to move until the error has been manually cleared. You have to clear the error in order to move forward. And I just kept getting this error every single time I would boot up. Oh, it wasn't every single time. It was probably like 70% of the time. It would boot up and it would say, oh, I've been disarmed because just but recently I didn't have enough power to move. I do have enough power now, but let's ignore that. Recently I didn't have enough power, so I'm not allowed, I can't move, I can't do this. And so now I've set up a system to basically detect, this is automatic on the TNC, it's just constantly listening out on the CAN bus, and whenever it sees that there's a brake resistor disarmed error, it just gets rid of it. It just clears it. It says, okay, cool, yeah, you've been disarmed, but now that error is cleared. What could go wrong? I hope we don't find out, but yeah, this seems to be working for now. Yeah, I obviously don't love that that's how I've done it, but it works. All right. yeah, I've got a couple of some other little side things before some cool. Well, I don't know. Yeah, we'll continue on with how I've laid this out. I have a new favorite tool. This tool is amazing. I'm not sponsored by the company that makes this, but I just wanted to share with you how good this tool is, because if any of you are as into 3D printing stuff as I am, this tool will make your life so much easier. It's an ultrasonic cutting knife. This one specifically is made by Hozo. They recently had a Kickstarter, and that's where I got this from. I love a good Kickstarter. But it is incredible. It's basically a little blade, which is like reasonably sharp, but not like insanely sharp. And when you turn it on, it vibrates like at like 40,000 hertz or something ridiculous. And it allows you to just like cut through plastic. Like, you do have to apply a bit of force, but you can just cut on through. And this is not a very good angle for me to do this at. You can see I can just no. And this makes it so easy to modify 3D printed parts. Like, you can see the quality of this cut. Why am I showing you this? I've got photos of it. I have never been able to make cuts this clean on 3D printed parts before, and this has saved me so many times. There have been many times where I'm like, oh fuck, like this part is like so close to being exactly how I want it to be, but I just need to like trim a little bit off. And previously, the only way that I could do this was with a soldering iron, which was like, it's messy, it was stinky, it gets all like gunky, and I don't know, I'm sure many of you have tried that before and it's not a very pleasant experience. Or a Dremel, which is kind of worse for me in this room because I have like carpeted floor, and using a Dremel just gets dust everywhere, and it's super not nice. But this, you can just cut. You just, like you do for some things, especially like this is quite a thick part, you do have to apply a bit of force, but you just glide on through. It is amazing. However, you do have to be a bit careful, as I realized. There was I was getting a bit too over-enthusiastic with this, and there was a point where I had these dowel pins inserted into a printed part, and I needed to get them out, and silly old me, when I designed the part, I was like, why would I need to get these dowel pins out? Like, I'm just going to build the part, and then the part's going to work, and then the dowel pins will be happy there. Somehow, I still have not learned this lesson of like, I believe I have changed this now. This is on this part. Let's open this up. What is all this? Get out of here. So now, what the proper way to do this is like in here, I have dowel pins, and I have set up in the CAD, so it's like a 3mm dowel pin, it goes into here, and then I have a 2mm hole at the end. And this way I can just like poke a thin thing in through this 2mm hole, and then poke the dowel pin out the other side. In this part that I'm describing now, I didn't have this extra little hole here, and I don't know, I was just like, why not try using my new ultrasonic cutter? Turns out it even cuts through metal. It has definitely damaged this, like this specific blade is now, like the very tip of it is a bit chipped because of hitting the dowel pin. But this dowel pin is obviously not usable anymore. So you do have to be kind of careful with where you're cutting, because you can damage stuff pretty easily. But it's such an amazing tool. I really recommend it. I'm a big fan. All right. Now, I just want to have a bit of a rant about Brummel splicers, because these were doing me in so hard last week. For some context as to what this is, in several places on Butler and in Joggerbot, we have strings being like the main actuating force, or like providing the actuation. And for all of my setup in here, the way that I've been terminating all of those strings is with a loop. And so what I really want to have is exactly what this is, where, let me open it up a little bit more. We have a loop on the end, and just a nice, clean string. There's no knot in here. How good is that? So clean. However, tying this is not easy at all. And this destroyed me. So, yeah, my problem, the general sequence here, I'll show you on a bigger one. The general sequence here is that you can pass through, and I strongly recommend as well, if you ever need to like terminate a string in, the big advantages of doing this that I think are probably worth making clear before I describe my problems with this, there's a couple big advantages. One is that you can position the loop exactly where you want it to be. Like with a knot, like I feel like I'm pretty okay at some knots at least, but getting that knot so that the loop is in the exact right position is very, very, very hard to do. I have never really been able to do it reliably. But with a Brummel splice, you can get the loop to be like to the like 0.5 millimeter where you want it to be. Very nice for that. It also does not slip at all. So if you tie this with like, there's no like settling in. Like once this is in, you can pull on this as hard as you want and it's not going to slip. Compared to a knot, where once you tie it, if you have that loop exactly where you want it to be, and then you pull that knot tight, it's going to tighten on itself and then stretch out a little bit, and you're going to get the loop is going to then move where it actually is on the string. That's a bit of a problem. This is also obviously a lot more sleek. So in my situation here, especially for the hand where the string is like running over pulleys, having a knot there is no good because that knot is going to like interfere with the string going smoothly over the pulley. There might be other advantages as well, but yeah, those are the big ones for me at least. And yeah, the general idea of how this works is you can see that this string is like woven. I definitely recommend looking up a video of this if you're interested in it, but you basically like pass the string through itself twice in different ways, and then you terminate it by taking like the loose end that you have remaining, and you feed that in through the middle of the rest of the string. So it's like a Chinese finger trap kind of thing. Like it's like one part, the end of the string is like inside the rest of the string. So the harder you pull, the harder it compresses on itself and the harder it grabs, and it just like makes it impossible to slip. But it also means that when you're using really small strings like this, it's very, very difficult to get that tail back through the main part of the string. And this is how a lot of my Brummel splices ended up. I've obviously done this before. Like this string that I was just holding up, the really small one, this is the exact same string, nominally, and I was able to do a Brummel splice in it. I am convinced now that, I'm convinced that my new spool of string is slightly different to my old spool of string in some very weird way, even though it's like, I bought them both at the same time from the same Amazon seller. They should be the same string. I'm convinced that they're different because previously I was able to do the Brummel splices without too much hassle. I tried for probably like 3 hours last week, and I didn't get any that succeeded fully. Like I think I tried like 6 or 7 different times to get it to work, and none of them I could get the tail to bury in fully. Because what was happening is I would insert my wire into the string, and this is actually, a good illustration of how this works. You basically feed through a wire with like a little bend in it like this, and then you put the tail in through that wire, and then you pull that wire back through. So when you're pulling it back through, you're pulling through 2 widths of wire plus the string folded over on itself. And you're pulling that through, this string is 0.8 millimeters diameter nominally. So it is very, very tight in there. And it was just getting stuck and getting stuck. I broke 2 of my partner's embroidery needles, which she wasn't too stoked about, but is what it is. And I could just never get it through. And it was just doing me in. And after a while, I know that John in particular is going to be very disappointed in this, but the actual string that's on Butler's hand right now is actually just 2 figure eights, which looks disgusting, but maybe I can actually show you. Let's see if we can zoom in enough. Why? No, that's not that. I don't think that's going to work. Yeah, it is just 2 figure eights though, but yeah, so it's a bit ugly, but it works. But because, thankfully though, I was able to tie those 2 figure eights very, very close to the hand. So those 2 knots, it's like, one is like here, and the other one's like in the same spot just above. So they are close enough to the hand that even when the hand is right at the top, the knot never interacts with the pulley. And actually, while I've got the card open, it might be a good time to just show you as well the way that the string is routed and how this is different to the Juggerbot's string. So in Juggerbot, we have the string just goes like nice, it's just like a very easy, clean, up, down, and around. But here, I think I showed this off last week, because I have this support for the yaw axis, for the pitch axis in here, I've had to redirect the string a little bit so that it goes kind of like inside the aluminium extrusion. And so this is the pulley that I'm unsure. This is the only pulley that's different between Juggerbot and Butler. And so this doesn't really seem to explain to me the significantly increased friction that we have in this system compared to Juggerbot's identical system, except for this pulley. Yeah. One other notable thing as well, I mentioned this last week, is that as this is here, as the string spools and unspools along the spool, the angle that this creates is going to get quite steep. And it actually was too steep. With the hand motor being positioned exactly where it is here, which is actually inside that for some reason. That's a bit weird. I need to fix the CAD. Yeah, with the hand being as low as it possibly could be, so that it didn't so that it was basically resting on this block. That angle was too steep, and as soon as I tried to move the hand back up, the string would come off of this pulley and then get stuck in this side bit. But thankfully, as I mentioned last week, this is very easy to fix because all I needed to do was just loosen up the bolts that attach this part and this part to the aluminium extrusion, and then just slide the whole thing up a little bit. So it's now, I don't know, probably 3 centimeters above where it is in the CAD. Yep. Yep. Also, one other thing is that you may have noticed that I have actually 2 things. One is that I've added a bumper in here, and I did spend a bit of time trying to figure out. So this is obviously the bumper that I made. Well, I don't know. You may remember I made this bumper months ago when I was just testing out some ideas, and I was holding this and I was like, okay, I know that I want to add a bumper in here because why not? I may as well. And this is just to stop, if the hand is really going pretty enthusiastic and it smashes into the end, the intention of this is that it will absorb a bit more of that energy than just a hard end stop would. And I spent a bit of time looking at this and I'm like, this can definitely be improved, because as it is right now, when I compress this down, the 2 points that contact each other, it feels like it's very possible to reorient this so that with the same initial height, we can get more compression out of it. I really think that's possible, but I was looking at it for maybe 5 or 10 minutes and I'm like, no, it works. I'm just going to keep it like this. So we have the same bumper as before, and that just slots in. I want to improve this so that this locks into the red part a little bit better, because as it is right now, this does have a tendency, if I continuously run the hand into that position, it does have a tendency to slowly wiggle its way out, and I don't love that. But I really don't want to use a fastener in here. It feels like a fastener is overkill. There is definitely a way to do this where it's just 3D printed, clicks in, nice and solid. But I'll keep working on that. Yeah, and the other big thing here is that you can see I've got a scoop hand now, and this is like this so that when the hand is when the pitch axis is down the whole way, the ball will still stay in the hand, even though we're right down the bottom. And that has worked really, really nicely, actually. I have not noticed any rolling problems, which is what I was concerned about last week when I mentioned this. I was a little bit worried that when the hand throws with a scoop like this, that maybe the ball might roll out as it leaves. But yeah, seeing it actually in operation, I realized that that's not really that valid of a concern. I think the ball is just moving so quickly, and it's such a slippery surface, and the plastic is obviously a very slippery surface. It just slides right off. So yeah, I'm very pleased with that. I think it works very nicely. And it's a very aesthetic print. It's such a smooth shape. Yep. All right, yeah, so back to the splices. So the tricky thing with this is that this loop of string, it will terminate, one end terminates in the hand down the bottom in here, and the other end terminates in the hand up the top. So this is one continuous loop the whole way around. It passes through here. I have it set up so that going through this spool now, on Jugglebot, it is actually tied on to that through this hole, so it can't, neither side can move, so it's effectively 2 strings. But in Ball Butler, I just have it passed through this loop, so I can actually slide the string along if I need to. But yeah, so it is just one long loop, and that means that we need to be pretty deliberate on how long this loop is for it to fit properly. If it's a little bit too long, we can tension the system using, let me just hide that. How can I show that edge? We can tension this using, there's a bolt up the top here. So I can loosen these 2 bolts and the 2 on the other side, and then get my my hex driver in here, unscrew this bolt. In the CAD, it's all fixed together, so I can't actually move it. But I can loosen this up, and then that will raise this red part up and thereby tension the string. And that works, but there's obviously a limit to how long that can be. Like this bolt is only so long, and I don't really want that to be like 20 centimeters above the top of the extrusion, because that's just going to get like wobbly and yeah. So, I mean, yeah. Yes, there's a limit to how long we can go. And obviously if the string is too short, then it's just not going to reach at all. And we do need to have at least like 1 or 2 loops around on the spool here to make sure that everything spools and unspools the way that it should. So this has to be a very particular length. And this is obviously the same thing with Jugglebot, but to be honest, with Jugglebot, I never actually really calculated how long the string is supposed to be before I tied it. I would just try it, and then if it was too long, I would just cut it down a little bit and tie a knot again, and then try it again. And once I got a length that worked, anytime I had issues, I would just copy from the same piece of string. I would just like get the string that's on there, measure using that, cut my new string, and then go again. So I never really actually went through this calculation process, and to be honest, I'm kind of skeptical that it's worthwhile. But you'll see why I mean that in a sec. So my process for figuring out how long this needed to be, and I'm very curious to see if anyone can spot where I have gone wrong, because I suspect I have. So I have the stroke is 310 millimeters. So that is the amount of length that the hand will cover from like the very, very bottom up to the very, very top. That's how much we need the whole system to be able to move by. We also have, according to the CAD, we have measured 841. This image here is a, like I've highlighted the whole string. So this loop of string, we obviously need to have, the string needs to be as long as this loop, plus the length of the stroke, plus whatever we need to tie the knots, is my general thinking, right? So we have this loop is 841 millimeters. The stroke is 310 millimeters. We have 15 millimeters of gap between the two loops. So that's like in here, between where the two ends sit. And so that means that the total loop-to-loop length should be 1136 millimeters, in theory. However, although that is not including like 1 or 2 loops around the perimeter. So maybe add like 20 mils or something. So maybe like 1150 millimeters. We then, because I was intending on doing this with a Brummel splice, because we can position the Brummel splices very, very deliberately, we need to know how big we want the loops to be so that when we tie the Brummel, it ends up where we want it to be. We have a perimeter of 30 millimeters per loop. I realized in my calculations, actually, I did not double this. This should be ×2 because there's 2 loops, but I've only included the numbers for 1. And then we want to bury 55 millimeters. So that is this length in here, this stuff that I'm like trying to it's called bury inside the main length of the string, that should be 55 millimeters if we want to have like 0 chance of any slippage at all. And so this means that the total cut length should be about 1300 millimeters. But then, oh, it's gone in a different order. But I also know that these strings do have a tendency to creep. And I really don't want this system to need to be tuned all the time. I don't want to have to come in and like re-tension the strings every little while. I would really like to just be able to set it and forget it and not have to worry about it again. So I thought I would include I thought I would pre-tension the strings, but if I'm pre-tensioning them, then I need to account for that stretch that it might have before I cut them. And I actually don't know if I've shown this data on YouTube at all, but one of the videos that I have been planning on making for a long time is, I've even got the title, Which String is King? How good is that? Oh, I've got so many aspects of this video done, but so many aspects not done. Video making is a lot of effort. Long story short. And this is one of my pieces of data where I basically strung up all of these different types of string with a 5 kilo mass for, I believe, a week, something like that. I think it was a week. And then I measured how much the string had stretched by. And we can see we are using this ultra high molecular weight polyethylene, also known as Dyneema. And that has a stretch of about 3%, or about 3.5% rather. And so if we include that creep amount, say about 3%, then we need to cut a little bit less so that once I pre-stretch this, it will stretch out to be the 1300 mil that I actually want. And I did this, and I actually have a video to show you of my setup. I had this, when I took that data that I just showed, it was a 5 kilo weight mass for a week, but I didn't have a week to wait. So what I did is I looped the string over my, like, what are they called, like the calisthenic rings. I doubled it over, so it is only receiving half of the weight, but I put on a 35 kilo mass. And because I really, this doesn't feel good. This string is so thin. It really feels like it's going to snap. So I put my, like an old tent underneath it just in case it broke so that the weights didn't come like smashing into the ground. And I also have 2 of these, which I will talk about in a sec, because I wasn't entirely certain that one would work. And there you can see my, this is the actual, this is the string that's on the hand right now. So you can see those 2 figure 8s there. And yeah, that comes up. So we had 35 kilos for about 45 hours. And it was heavy enough that it actually cut into my calisthenic rings. So yeah, pretty substantial weight. Hello, Batboy. Nice to see you. I'll do another demo at the end because I'm not gonna be able to help myself. But you gotta wait for that. Or you can scroll back to the start. So the results of this test, and so keep in mind, we would expect 3% creep. That's what we should be getting. Ish. Thereabouts. String 1 had 1 Brummel splice and 1 figure of 8. And that Brummel was one of these ones that like didn't terminate quite fully. Like I think it was very, very close to this, where like it's sticking out just like a little bit, but it's mostly buried. So it's mostly fine. That string started off at 1265 millimeters. So it was within, I don't know, approximate bounds. It ended at 1285, so it only stretched by 1.6%. Not very much. String 2 had 2 figure 8s on a byte, which I would expect to stretch more because those knots are going to tighten on themselves and allow more string to get through. This one was a bit short, started on 1025, ended on 1098, stretched 7%. Nuts. So I'm like, I don't really know what to make of this information, because one of them is stretching by like barely anything, and the other one's stretching by heaps. And like, maybe it's the knots, but surely not that much. So I don't know. After all of this, I'm like, I don't know what to do with this. I'm just going to keep doing what I did before. And now I know that this, one of those strings was too short. The string 2 was too short. No, the other way around. String 1 was too long in this situation. So 1285, even though my calculations said 1276, it was too long. So I had to go to the other string with the 2 figure 8s, and that worked perfectly. And after all of this, I think what I'm going to do in the future now is just, if I need to restring this at any point, I'll just do what I did before and just measure using the string that I already have, that I know works, and I'll just copy that. And of course it will be like ever so slightly different because the knots will be in different spots, but yeah. Honestly, the biggest takeaway after all of this is that I am very confident that for all future designs that I work with strings, I'm going to use a bigger string. All of these, maybe not all, a lot of these problems will be gone if I just used a bigger string. Because you can see this one, I Brummel spliced this in like 5 minutes. No worries at all. Calmly, just follow the steps and it just worked. Easy peasy, done. And it's like a nice clean, I probably could have like tapered the berry a little bit more to get it to be a little bit less of a drop there. But other than that, like pretty straightforward. But this tiny little like 0.8 mil string is just too damn small and too fiddly to do. The reason I've got a band-aid on my finger is because I slipped at one point and like cut my finger pretty annoyingly while trying to tie these. And like my hands, like I had like cuts like in here from like wrapping the like string around my hand and like trying to pull it. I literally was like bleeding in like the corner of my pinkies, which was not fun. So definitely, yeah, if you're doing string work, use like reasonably sized strings. I don't know if I'm going to go to this size because this is like significantly bigger than what I'm currently using, but I think something in between would be perfect. And of course, that means it will creep less. It will be significantly stronger. It'll just be super solid. Yep. All right. That's the end of my slides, but I know that I have a lot more to say. Let's do another demo. I want to do another demo because it's fun, and why not? All right, so let's try actually. Let's have the ODrive S1 unplugged, And we'll power it on. No, alright, we're getting the red error. Let's try one more time. No. Let's try plugged in. And now it works. Amazing. And my ROS thing is still running. That's been running the whole time. Let's see if that's still living. How good is that? Oh, I love it so much. Oh my god, the camera keeps fucking moving. This thing gives me the shits. Alright, let's do one more throw and then I'll wrap it up. I'll hide the Arduino stuff as well because we don't need that. Oh, that's a good view. Right on my bum. And of course, it's a bit lame if it like starts in the position where it's throwing. So let's spin him around a bit. Let's go. And then we can move the pitch axis a bit. And then now we can throw. Yeah, you can see that wobble. The wobble's pretty bad. Now we'll align itself. Whoop, whoop, whoop. Get to where it needs to go. So good! Ah, it's so satisfying. In case you didn't hear Batboy as well, this is I'm definitely cheating a little bit. This is not actually tracking the catching cone. It's just throwing to like a set. Like I can command an XYZ position. Like let's see if I can get it to throw to me. If I can guess the XYZ. And I think that the XYZ is like, I think that Y is up this way and then X is this way. But I'm not 100% sure. I just kind of like trialed and errored a bunch of different numbers until I got it to work. So let's try. Maybe. What are my coordinates? Let's see if that will work. I'm going to X is 1 meter, Y is 0.5. Oh, that was pretty close. A bit far away though. Yeah. It's a lot of fun. It's a very, very satisfying system. I am very happy with how this has come along. It's so good. It's so good. I love it so much. Alright. That's enough rambling. So, yeah, it's probably worth talking about as well. So, yeah, this will probably be the last stream for this year. I would be very surprised if I have any more this year. The reason for that is because I've got my wedding in a couple of weeks and I need to go up to the venue is my parents' property and I need to like help with some landscaping work to get it ready for the wedding. And then after that, I'm going on my honeymoon. So I won't be back until December and I'm probably going to be busy in December doing some other things. I expect to do a lot of Ball Butler work during that time as well. But to be honest, there's a lot of like, to go from here to like Ball Butler on the shelf, collecting balls from the dropper and throwing them into Jogglebot, I think is just going to be a lot of like software noodling around, getting into the, what did someone say? The code hole. I'm going to go deep into the code hole. And I don't think that's going to make for very exciting content. So yeah, it's possible. My goal is that I'll be able to get this to work without taking too much time. Like maybe during December, I'll be able to get it to work. And then I want to make like a proper, like flashy YouTube video on this. And I'm hoping that maybe I can get it to be like less than 10 minutes. I figured that because I've got all of this like backlog of content, like if anyone wants to see how this was developed, this is the stuff to watch. So I feel like I can, because I have these streams, it feels like it's affording me the ability to make like much shorter, proper videos to like keep them like maximum like entertainment sort of thing. Batboy says, lol, if you need help with code hole, let me know. Thank you, I appreciate it. I will. Some other thing, yeah, I think it's just time. It's really just sitting down with it and just nutting it out. Yeah, actually there's one big thing that I want to mention. Theodore, thank you for your congrats. And Batboy, thank you for your well wishes. One thing that was that had me very worried last night. It was like 2 a.m. or like 2:30 a.m. just as I had started sending commands from the Jetson to Butler. Because prior to that, I was only ever commanding things with like the Arduino interface. I was just going like yaw to this angle, pitch to this angle, throw to this speed at this speed, and it would do that. But to like bring them all together, of course, I wanted to get that to work off of the Jetson commands, and I didn't realize at the time why this was happening. But what I was experiencing was that I could send one can command per instance of running ROS. Like I would boot ROS up. I could then send one command before the future commands just were not getting sent. And I had to shut down ROS, close the CAN bus on the Jetson, reopen the CAN bus, and then restart ROS again, and I would get one more command. And you can imagine how that felt when I was trying to calibrate, because like I don't know where the local XYZ is for, according to Butler right now. Like that's just some like arbitrary angle. So trying to calibrate like where the catching cone needs to be so that the ball will land in the cone, that took some time. It's like boot it up, hope that these numbers are right, run, hope that it's gone to the right position and thrown at the right speed. And it's like, okay, cool. Now that missed. I need to change my numbers ever so slightly. And it was like every 5 minutes, like, yeah, I would get like one go every couple minutes. As soon as that was part of the reason why I kind of gave up on the mocap idea, because I'm like, nah, this is just taking too long. And the ball keeps hitting the ground and I'm really worried because like my bedroom is like right next to this room and I did not want to disturb my partner, just like dropping balls on the floor at 3 a.m. So I decided to I'm like, all right, stuff it. I'll cut it out. And that's why I said at the start of the stream that I gave this, like last night, I was giving this demo like a 30% chance of working because half the commands just weren't even being sent. I'm like, what the fuck is going on? Like, why can't I send these commands? As soon as I walked in here this morning and I looked over my system, I realized that I had not connected the grounds of the Jugglebot stuff, Butler stuff, and the Jetson, which meant that I was sending CAN commands from like one power source to another. It's like the Jetson was like referenced to its ground, Butler is referenced to its ground, and both of those CAN signals, like they're trying to read the CAN signals from each other, but because they're not referenced with the same, like with respect to the same thing, it was just creating issues. I don't know why I was able to send one command and then never any more. I don't know exactly why I was having the symptoms that I was. Thankfully, yes, Fatboy says it's a floating ground, the grounds did not agree. And as soon as I walked in here, I'm like, oh shit, I need to connect my grounds. And that was it. As soon as I did that, I can now, we can see ROS has been running like literally the last hour and a half. Ever since I started the stream, ROS has been going the whole time, and I can just send as many commands as I want. Exactly how a CAN bus should be. So yeah, check your grounds. And I'm glad that I stopped at 2 a.m. because I don't think I would have realized that last night. That was not, I remember very explicitly thinking like, oh shit, I'm going to have to like get out my CAN analyzer thing, like the USB to CAN thing, and like I'm gonna have to go through this whole like every time I've had to debug the CAN bus, it's just such a painful experience, and I did not want to have to do that. So I'm glad that I didn't do that, and I just slept on it. And as soon as I walked in, I'm like, oh, stupid error. Yeah, so you got to be careful with that sort of stuff. Yep. Yeah. So anyway, back to my plan. I want to make a proper YouTube video on this, and then return to Jugglebot stuff. But depending on how the development of Butler goes, I may or may not start doing these streams again before doing that big video. If it turns out that there's actually a fair bit of development that needs to be done before making that video, then I will probably start the streams again, like in January kind of thing. But it's possible that you may not hear from me until like February or March, because making this video is probably going to take a little bit of time. Maybe not 3 months, but you know, under promise and over deliver is what I like to live by. Yep. Yeah, cool. All right. There's a lot of stuff that I haven't talked about as well. So if you're interested, I definitely recommend poking around the CAD. There are some new things in there, some little Easter eggs if you're, I don't know, so curious about it. And yeah, I guess that's it. Yeah, we made it. It's kind of working. All right. Yep. I'm going to save you from my mindless ramblings. I know that I have more to say. And I know that in 10 minutes I'm going to remember it and it's going to piss me off. But I can't remember off the top of my head right now. This is the problem with getting 5 hours of sleep. Yes, Fatboy says, the USB to CAN devices are frequently painful. Yeah, I don't get why they're so bad. I don't get it. Like, CAN buses are used so much. Why are there no good debugging devices that aren't like $400? I don't understand. All right. Yep. Calling it. Thank you for watching, and I hope you found this interesting. And if you have any suggestions for anything, as always, please do let me know. And yeah, any feedback, any observations, I am definitely keen to hear them. Yes, I hope you enjoy the rest of your 2025 with whatever that may bring. Good luck with whatever projects you are working on, and I will see you at some point. Until then, have a good one.